Hello, everyone. Thank you for attending today's webinar titled Enhancing Composite Durability and Aesthetics with PVF Film, brought to you by Composites World and presented by DuPont. I'm your moderator, Scott Francis, editor of Composites World. Today's presentation will last approximately 30 to 40 minutes, followed by a question and answer session. If you have a question, you can type it at any time during the webinar in the Q&A section of the chat. There's also a poll that will be happening during the webinar, so keep an eye out for that. The webinar is being recorded and when complete will be made available to you via email from Composites World. Our presenter today is Sanahan Vijay Akumar. He's an application development leader at DuPont and spends his time identifying and leading new technical programs for the global business across market segments. Sanahan, I'll hand it over to you.
Thank you very much, Scott. And before that, I'd like to say hello to everyone and thank everyone for attending today's webinar. And I'm very excited to talk to you about Tedlar and enhancing composite durability and aesthetics using Tedlar PVF film. So let me get started with a brief introduction. So what is Tedlar? Well, Tedlar is polyvinyl fluoride, or PVF. It's really a unique and highly durable polymer that's been used across a wide range of industries for decades. And it was first commercialized by DuPont in 1961 under the Tedlar name. And DuPont has been producing Tedlar PVF in the forms of different films as well as coatings for over 50 years. Proudly made in the USA, one of the hallmarks of Tedlar is that over the years, it's been its ability to evolve, really finding new uses and expanding into new and different applications. Whereas like today, you'll see Tedlar commonly used in applications such as metal composite panels, architectural fabrics for construction, graphic signage protection, wall coverings, awnings, and even aircraft interiors. So it's really this wide range of performance benefits and versatility that makes Tedlar really such a strong fit for many composite-based applications. And because of that, I'm excited to show you how it really continues to enable innovation across the many different industries. So there are three key words here: durable, flexible, and proven. And personally, I think are really core tenets that best represent Tedlar. And these are words that I'll be using throughout the talk as well, and you'll hear it a lot. So now to emphasize on durability. PVF polymers really kind of known for their outstanding resistance to sunlight, degradation, chemical attack, water absorption, and many, many different solvents. It's really thanks to these properties that PVF films and coatings are really widely used in both indoor and outdoor applications, either for functional or decorative purposes, showcasing and highlighting its flexibility. So Tedlar films and coatings are trusted really in environments where proponents such as thermal stability or chemical resistance, outdoor durability, dirt and stain resistance, as well as specific adhesion or release characteristics are needed and critical. And another key advantage of PVF is that it's stable at high temperatures. Really, that's something that is essential in today's many demanding applications. When we want to talk about proven, especially when it comes to performance, Tedlar's long-term durability is what really stands out. And it's its key attributes that have been tested and validated for over 50 years of continuous exposure in what we call harsh coastal South Florida conditions, conditions with a lot of sunlight, a lot of salt, seawater, and really a lot of wind, sand as well. And combine that along with our internal rigorous accelerated lab aging testing can show that Tedlar can be long-term, durable, and flexible, and is proven after all this testing and continuous exposure. So moving on and building upon these decades of proven performance, Tedlar films have been used globally across a wide range of industries, including building and construction, aerospace and transportation, protection for both graphics and signages, photovoltaics, and even wall coverings. And it's really due to its durability and flexibility that makes Tedlar such an ideal solution for protecting both interior and exterior surfaces. And it also lends itself to more specialized industrial applications where one may need a specific surface finish. Now, with that in mind and covering some of the overview of Tedlar, I'm excited to share some of the many different applications of Tedlar. And let me start off with, outdoor surface protection. And it's really Tedlar's exceptional outdoor durability that is one of the reasons why it's so widely used in buildings and construction environments, as well as in outdoor graphics and signage protection. So PVF and Tedlar PVF, unlike other plastics or even other similar fluoropolymers, doesn't break down in harsh environments. So it resists fading, it resists abrasion, and resists deterioration of its mechanical properties. So it really offers a reliable and long-lasting performance in all sorts of and all kinds of outdoor conditions. And it's these critical properties that are retained to a significant degree even after continuous exposure in South Florida's tough coastal climate and under our accelerated aging tests. So its weather resistance, its chemical inertness, and mechanical toughness enables Tedlar to be used widely as a protective surface for metals, hardboards, different felts, different plastics in architectural, decorative, or industrial settings. So now when moving on to indoor applications, it's Tedlar's inherent chemical resistance and also its inertness that really make it a great choice for indoor surface protection. So Tedlar films offer excellent stain resistance and are rather easily cleanable. It's its ability to withstand really a broad range of solvents, which means that Tedlar's PVS surface won't fade or streak. Most importantly, even after frequent or aggressive cleaning, making it valuable in high traffic areas that require a lot of cleaning and need to be durable to withstand that. Tedlar films also can resist mold, mildew, and bacteria, and they're durable enough to endure the repeated cleanings without degradation, which make it perfect for healthcare environments such as hospitals, which require sterile materials. And on top of that, Tedlar PVF also has a low smoke emission and low smoke toxicity, which really makes it ideal for aerospace interiors, where stringent safety standards do apply. But really, beyond these outdoor and indoor applications and the architectural and aerospace use cases, its Tedlar's strong mechanical properties and non-reactive surface it can make it an excellent material for release films. And Tedlar release films are widely used in both rigid and flexible composite-based industrial applications. In fact, Tedlar release films can also impart distinctive surface appearances or different textures, such as grippiness or slipperiness to an underlying substrate, really giving and adding another layer of functional and aesthetic value. So moving on, and after showcasing some of Tedlar's properties, this is what some of Tedlar's films look like. Tedlar PVF films are available in a wide range of different colors, as well as what we call a clear film, translucent and transparent films, as shown on the bottom right corner of the slide. Generally, our colored Tedlar films are more on the matte side of things for color, but we're also capable of producing glossy and metallic films for certain specific applications. So these films are also available, in a wide range of thicknesses and flexibility levels depending on the durability required for the application or the specific elongation properties required when processing. So it's here where our team would work with you to select the right film for your specific application. And we also have samples of our many different films available for requests on our website. And we do encourage you to reach out to us for any samples as well. So moving on and really talking about a topic that's currently in the news, since PVF is a fluoropolymer, and many of you may already be familiar with, the many ongoing conversations around PFAS, and particularly, PFAS undergoing overall increased regulatory scrutiny. Therefore, this is why I want to spend some time to explain the subtle differences and explain why it's really important to understand the many different common themes in the many regulatory definitions and the subtle chemical differences in chemical structure. And these are definitions that have been under evaluation for years by multiple regulatory organizations around the world. But really, to kind of explain and put it simply without jumping into the chemistry of things in depth, for a material to be classified as a PFAS, it must contain at least one fully fluorinated carbon atom. That is, it's a carbon where all its hydrogen atoms have been replaced by fluorine atoms within the polymer unit. So let's take a look at this slide here, and we can see the picture on the left, which is a PFAS polymer. When looking at one of the carbons, we can see that it is fully fluorinated, in which all of the atoms bound to that carbon are fluorines. When we look at the chemical structure to the right, we can see for PVF that it is not a PFAS, as neither of the carbons are fully fluorinated. It only contains that single fluorine atom. And in simplest terms, it's a way to distinguish the differences between PVF from other PFAS regulated materials. And it's the European Chemicals Agency, or ECHA, which has led multi-year assessment on this, and it's really widely recognized as a global standard in regulatory evaluations. But not beyond just this, and more importantly as well, when it comes to PFAS regulations, PVF in particular does not break down into any end products that are classified as PFAS arrowheads, nor is PVF manufactured using any PFAS compounds. This means throughout the life cycle of PVF, it does not go through or deal with any PFAS compounds or break down into any PFAS arrowheads. This really gives us the confidence that PVF will remain compliant under future regulatory frameworks. And in fact, all current published literature by the ECHA, organizations like the OECD, and the EPA have all kind of recognized that definitions of PFAS, and in many cases, PVF is specifically called out as a non-PFAS alternative. And in fact, let me quote let me give you a quote from the ECHA. And here, polyvinyl fluoride is a partially fluorinated fluoropolymer and is not a PFAS. It could be a viable alternative fluoropolymer to polymeric PFAS for certain applications. And really, that's the best quote that we can get, showing that PVF doesn't fall under those PFAS regulations. So now moving on, after going through a bit of an overview about Tedlar, I'd like to talk about how one can apply Tedlar. And I'll really start off in its simplest use case. In this case, really creating Tedlar composites through lamination. So it's really Tedlar's flexibility that makes it ideal for applications onto a wide range of flat substrates through the process of lamination. And this could be many different substrates, including aluminum or stainless steel or different thermoplastic sheets, as well as vinyl substrates. And we at Tedlar have developed a range of adhesives that are specifically designed for laminating Tedlar PVF films onto these many substrates. That said, and going back to that point on flexibility, Tedlar films are also compatible with a broad range of acrylic-based adhesives. And this really gives manufacturers this additional flexibility in their manufacturing processes as well. However, using Tedlar's purpose-designed adhesives after curing, it's possible to achieve high quality and long-lasting bonds between the Tedlar PVF film and the substrate of choice, thereby meeting demanding specifications with leading adhesion performance. So now laminating Tedlar films onto substrates is rather simple to integrate into many existing downstream manufacturing lines. For example, take the schematic on the bottom left, which is a simple roll-to-roll manufacturing line. Um, in these processes, Tedlar film can be coated with an adhesive and then applied onto a substrate using nip roll lamination as shown here. But in more complex applications, for example, like flexible sign faces or even fabric structures, adhesives can be pre-applied onto the Tedlar film itself, allowing for easier lamination, thereby eliminating one step of a manufacturing process. And as I mentioned before, also, these Tedlar films are also available in a wide range of thicknesses and different tailored shrink properties, which allows it to be successfully laminated onto more complex shapes without any visible defects or any performance compromise, most importantly. And moving on from just simple flat structures, we can really expand manufacturing through different forming methods. And this is thanks to Tedlar's PVF inherent thermal and mechanical properties, as well as its processing capabilities as films or laminates or composites. And this could be extended really to produce more complex finished shapes and parts for both protection or decoration. Tedlar film generally can often serve as a lightweight, high performance alternatives to paint coatings in many end use applications. But not only does this reduce any added weight, but also provides superior barrier protection that Tedlar films provide. And here, when it comes to thermoforming, like many thermoplastics, Tedlar PVF films can also be thermoformed into specific shapes using a variety of standard plastic forming methods, such as vacuum forming, pressure forming, or even match die forming, like the schematic shown on the bottom left. So, after forming a shape, for example, using Tedlar composites or laminates, the parts can then be trimmed to achieve a final three-dimensional shape instead of a one-dimensional flat shape. But really, more importantly, and the best part of this is even after this downstream processing, Tedlar films continue to deliver the same key performance benefits in the final molded part. So you get that chemical resistance, you get that inertness, and you get that durability and flexibility. Really, some of the most common applications where Tedlar films are used in thermoform processes include aircraft interiors, the interior of public transit buses, different automotive trims and fascia, as well as components in turbines and very specific industrial equipment. So, moving on, I'd like to talk about another forming and processing flexibility, and that's the inverse, which is cold forming. And to really highlight and showcasing this processing flexibility of these Tedlar films, these Tedlar laminates can also be cold formed into complex shapes. And this is really thanks to Tedlar's high elongation and formability properties. It's this flexibility that extends across a wide temperature range, enabling cold forming from room temperature all the way down to cryogenic conditions. So if you look at the photo in the middle here, so it's one of the key advantages of Tedlar is that it does not crack under significant stresses. So even at what we call more extreme bends, like a 0T bend, where a sample is bent all the way 180 degrees, means that Tedlar film does not crack. And when you compare it to PVDF coated steel, you can see that cracking that is there. So this means that these laminates can be shaped easily using a variety of cold forming methods, such as bending or stamping or rolled forming, stretch forming, and deep drawing to really get your shape of choice without losing performance. You'll commonly see Tedlar films in cold forming processes for things like bent laminated metal panels and roofing, like the photo showed on the right, as well as stamped car parts in the automotive industry shown on the bottom. So even with these demanding processing steps, Tedlar retains its protective performance. So looking at the roofing photos, you can see that Tedlar, a coated roof on the bottom, installed 18 years prior to a non-PVF or a PVDF coated roof after 20 years. It is because of Tedlar's durability and chemical resistance that you don't see any of the corrosion of those metal roofing. And Tedlar retains these protective performances even and its key attributes even at the part bends, which are the areas that are typically the most mechanically stressed areas. So moving on from different forming methods as well, Tedlar can also be used as a release film. And this is due to Tedlar's high tensile strength, its inertness, and its anti-stick properties. And it's used as a release film for processing materials like epoxies or phenols or different polyesters and even rubber compounds. And in fact, here I'm showing you three common examples where Tedlar release films are used. So the first one is transfer printing, and it's a rather interesting application where designs and labels can be screen printed directly onto a Tedlar PVF sheet surface. And then these printed films can then be used to transfer a design right onto a rubber compound. This is commonly used in rubber hoses and fan belts to really put a label onto that, and having Tedlar release films used to impart that design onto the belt. Now, Tedlar films can also add a surface finish and texture, and it can impart, a wide range of these appearances and textures, giving, a grippiness texture or a slipperiness to either a matte or glossy finish due to Tedlar release films. And this either adds either a functional or really an aesthetic value in composite products, particularly like sporting equipment, where it enables customers to have a real customized look and feel of their products. And finally, moving to substrate forming, since Tedlar films leave no residue or surface contamination, it really becomes key for applications that require a pristine finish throughout the process. For example, circuit board manufacturing. And it's here Tedlar's mechanical strength, which allows it to shrink with the substrate during forming, helping minimize any surface defects in the final form part. So now that I covered some of the different processing methods of Tedlar films, I'd like to show and share some real world case studies showcasing Tedlar in the field. In fact, I feel like some of these case studies are the best way to really see Tedlar's durability, flexibility, and long term proven performance. So, here, for example, we have some photos of showcasing metal wall panels laminated with Tedlar. So take the top two photos here, highlight just how durable Tedlar laminates are. So we have both structures that were built over 40 years ago, yet they virtually show no visible color change. So take the image to the top left of this 43-year-old steel facade. When you compare that to a fresh film sample, the color is virtually indistinguishable, which is a testament to the color fading resistance that Tedlar films provide. And this is the same with this picture on the top right, which is a Paris skyscraper hotel, which still remains bright and clean after 50 years without any yellowing or any chalking. Now, moving on to the bottom set of images, now to the bottom left, for many of our soccer fans amongst us, you may recognize this to be Wembley Stadium in England. And here, Tedlar was used, where the roof lights are protected with where we have our clear Tedlar film, which offered exceptional resistance to weathering and UV protection, helping the roof lights of the structure look just as new and fresh as when it was first installed. Now, in the bottom right photo, when you compare Tedlar to alternative polymers like PVDF, we can really see and compare a stark difference between the durability of Tedlar films to other alternatives. In cases like this, on the bottom right photo, we can see Tedlar on the top of the plant interior roof, which is over 8 years old, and on the bottom, which is a PVDF coated roof, which is about 2 years old. This difference is drastic, and Tedlar's superior moisture and chemical resistance really help prevent any rust or corrosion of the underlying metal. ultimately extending the lifespan of this entire system. So now moving on to other case studies, here's some recent examples of how Tedlar has been used in wall covering applications. So on the top here is a case study in the United States. So between 2020 and 2021, Subway, the sandwich chain, underwent a major remodeling effort, refitting over 11,000 different restaurant locations with Tedlar wall coverings. In these high traffic environments, Tedlar wall coverings were used to minimize the need for replacement. And that was what was key for Subway. It was Tedlar's durability and resistance to, harsh cleaning agents that really made it an ideal solution to withstand, constant wear and tear, and still maintaining a clean and professional appearance with Tedlar's durability. Below, here's another great example, but this time in the healthcare space. So what we have here is a medical center in China. Tedlar PVF films were used all throughout the hospital in different applications, such as interior metal panels, as well as wall coverings, and even wardrobe finishes. So it's because of its strong chemical resistance and Tedlar's antimicrobial properties, which ensures, a highly sterile and long-lasting performance in this demanding healthcare environment. I'd like to move on to a little bit of aerospace and transportation because it's one of the major sectors where Tedlar sees widespread use. Now let's look at the left. Take most train interiors, for example, like those on Amtrak trains in the United States. If you can visualize and envision them, they often feature really like a gray stone pattern that's embossed with a Tedlar film and laminated over the surface. This Tedlar film is used to not just enhance the appearance, but also add a tactile feel as that film is embossed as well, and also protects the stone patterns. This can also be seen in trains in Europe, where Tedlar films with a wood grain finish have been applied onto these train interiors, giving kind of a warm, natural aesthetic. So you can get both tactility and feel as well as aesthetic with Tedlar films. And I'd like to say, moving on to other real world applications, Tedlar is also something that many of you have most likely encountered during air travel. So if you've ever rested your head on the side wall of a plane, it was probably on a Tedlar film. And this is because Tedlar films are commonly used in the fuselage or the side walls of planes. But looking at this picture here, its present extends way beyond that to many other applications in aerospace. And it's because, and thanks to its wide range of performance properties and the many different processability options that Tedlar has found in these other parts of the aircraft, really showing its value in environments where materials must meet the strict regulatory standards used in aircraft applications. So now moving on to applications of release films, here we have a great use case of Tedlar release films in sporting equipment. In this example, swim fins for swimming, snorkeling, and diving. So here in this example, this specific manufacturer printed patterns onto an FRP panel and then used Tedlar release films to achieve a fully matte finish on the final fin. So beyond just having a nice matte appearance, these release films can also impart surface texture, allowing grippiness or slipperiness on the surface, depending on any of the desired performance. And it's a great example of how versatile processing capabilities and how versatile Tedlar is and can be tailored for something that can be used for both form and function. Here, this is one of my favorite slides. because it really shows the versatility of Tedlar PVF films when it comes to designs. So you're not just limited by the colors or the pigmented Tedlar films or clear films. You can really see a wide range of different finishes or patterns or textures that have been directly printed onto Tedlar PVF films. Now, with this level of flexibility, the possibilities are virtually endless when it comes to protecting or enhancing a specific design for aesthetics, durability, or even both. And now, finally, here is a great example of Tedlar used in graphics and signing applications, showcasing its stain-proof surface and excellent cleanability properties. So, looking at the main image in the middle, when you compare Tedlar to other polymers like PVDF or standard vinyl film, Tedlar stands out. It can easily be cleaned without leaving behind any ghosting patterns that's really seen on a PVDF over laminate, or doesn't damage the underlying substrate like seen by standard vinyl. So you can see the same advantage with wall coverings or Tedlar wall coverings shown on the right. And on the far right, we have a Tedlar wall covering and a standard wall covering to the left. Stains are effortlessly removed using common cleaning products without damaging the surface. It's simple, but really a powerful demonstration, really showing how Tedlar can be durable and easy to maintain over a long period of time. Now, with that, I'd like to thank everyone for attending today's webinar. And before moving on to questions, like to encourage everyone to please reach out to our team. Either I or any of my colleagues would be happy to answer any questions or even send you samples. We really do enjoy working with our customers to help them find the best Tedlar PVF solutions for their needs. Thank you once again.
Sanahan, thank you so much. We have a few minutes to open things up for questions. Attendees reminder, if you have a question, you can use the Q&A panel in the chat. As a reminder, the webinar is being recorded and when complete will be made available to you via email from Composites World. So let's dive in. So first question we have is asking about Tedlar's scratch resistance. Can you talk a bit about that, Sanahan?
Yeah, sure. In fact, Tedlar, really underscoring its durability, is highly scratch resistant and passes ASTM scratch tests. I just can't recall the ASTM standard number, but we do have a lot of key scratch testing results and performance data, which if you are happy to look at our website, I can find that information, or if you reach out to us, I'm happy to share a lot of that specific technical information.
What is the processing temperature range for thermoforming?
It's a good question. So I kind of gave an overview of just how versatile Tedlar could be. So really, uh, Tedlar's temperature ranges are rather broad. So it really depends on whatever specific thermoforming process that's needed on your specific use case as well. But since the processing range for Tedlar is rather flexible, it enables for a wide range of thermoforming or even cold forming applications at higher temperatures too.
Okay. What standard what standard adhesive coatings does DuPont offer with Tedlar film?
Yeah, that's a great question too. So, you want to attach Tedlar film to different substrates. You know, DuPont, we offer two different adhesives that we have created and rigorously tested, and really have also decades of case study data for both, indoor uses and outdoor uses as well. And, we're happy if you reach out to review the properties of our different adhesives and select the appropriate adhesive for your application. But beyond this, and really showcasing Tedlar's flexibility, it is also compatible with a wide range of adhesive types. So if you're using a specific adhesive for your processing or use case, it is highly possible or very possible that our Tedlar PVF film will work well with your existing adhesives. And once again, I'd like to mention our team can support testing and adhesive selection as needed too.
Can you talk about recyclability of Tedlar?
Yeah, it's a great question. It says definitely something I'd like to be happy to talk about at a and into more details offline as well. We do have different options for that. So, but the thing is, with Tedlar, we have long-standing use cases as well for multiple years as well, and proven studies for over 50 years on buildings. So we don't anticipate it needing to be replaced after a long period of time. So really showcases its long-term durability.
For prototype evaluation, can Tedlar be hand applied to compound-shaped metal or composite surfaces with a hot air gun or Teflon-coated iron?
So yeah, that's a great question. In fact, we do even have what we call a Tedlar tape, in which there is a pressure-sensitive adhesive uh, on a Tedlar film that can be used to apply on very specific shapes as well. So um, yeah, it really, once you can get a curing range or the applicable curing temperature, you can adhere Tedlar films to more complex shapes as well. So we really have the versatility to apply Tedlar onto different substrates, and we're happy to work to really find what appropriate film and adhesive can work best for your required need and application.
How do PVF films compare to PVF coatings? Are there advantages or disadvantages?
That's a fantastic question, and in fact, we have a lot of customers who utilize PVF in their coating applications too. But a lot of the main characteristics and performance benefits are translated in both film format and coating format too. By being in a coating format, we provide a Tedlar PVF resin. It enables customer to have other additional tuning properties for their coating needs. And with our films, we could tailor films as well for specific needs, but we also have films that have identical shared properties to that of our coatings too.
So this one comment says, would like to see how to apply Tedlar film on fiberglass parts. I imagine this may be something that you need to show them directly, but I wonder if there's anything you can kind of convey right now ahead of reaching out to them.
Yeah, I would say, the best thing for that is, if you'd like to reach out and to us, we'd be happy to really identify how you can apply Tedlar onto your specific component or substrate as well. So, at least by reaching out to us, we can get this discussion to really identify the specific film and adhesive for your needs there. So please, I do encourage that, and we can definitely showcase a lot of uh, our existing case studies on different substrate materials too.
And this might be a good time just to say that all of the questions will be provided to Sanahan so he can follow up with you directly as well if there's more specifics that he wants to get into. Next question, can gouges and scrape damage be repaired with patches applied with heat and pressure?
Um, yeah, so in that sense, as I mentioned in a previous question as well, we do provide a specific, what we call Tedlar repair tape, which does have a pressure sensitive adhesive to specific areas that need, to cover up, or areas that may be damaged and all that. So it gives a lot of versatility and uniformity to really fix, small or hard to reach substrates or parts.
Okay, it looks like we have a high temperature question. Can Tedlar films be processed in thermoplastic processes where it is subject to temperatures up to 430 degrees Fahrenheit, 220 Celsius? Are there PFAS concerns with higher temperature processing?
Yeah, other great questions. So when you're looking at, temperatures at that range as well, we're definitely going up to the higher limit or the upper limit of operating temperatures for Tedlar or, processing Tedlar. It is for thermoforming, however, very stable at, those and processable at those high temperature ranges. And really, too, when you expand this further into any PFAS concerns, the good thing about PVF, and I'd like to expand, is that when it does fully break down, it breaks down into uh, byproducts, or what we call PFAS heads that are not of significant concern. So things like mineralized fluoride or other hydrocarbons as well. So really all of those degradation pathways as well have been well studied as well and don't have any PFAS concerns too.
Why does Tedlar show better stain resistance than PVDF?
So yeah, one of the great properties of Tedlar is that it is rather chemically inert and chemically stable as well, even when compared to PVDF. So it makes it ideal based on its chemical structure, how it's bond as a film, and its durability, which makes it very useful in applications where you need to you know removal of say different stains or graffiti using harsh chemicals and cleaning agents too. So in fact, unlike PVDF, PVF also does not ghost or leave any residue as we see in our laminates here. So it's one specific advantage of the film versus other competitive alternatives out there.
Are bilayer films offered where Tedlar is pre-bonded to other thermoplastic films?
It's a great question. In fact, I think this is something I'd be happy to answer if you'd reach out to that. We do have, different examples of which we have Tedlar bonded onto a wide range of different substrates and materials too. So we'd be happy to go through the list of different materials where Tedlar has been bonded and laminated onto, and can answer those questions to your needs. Yes.
Are the film and adhesive optically clear?
Good question. So, what we like to consider our clear film are are technically we provide a transparent and a translucent film, and there are certain additives that could be used to these so-called clear films for, say, UV blocking and UV protection, which may slightly alter it from being fully optically transparent or fully optically clear from there. So but we do offer multiple types of clear films, as we call it. So based on whatever specific needs, we can recommend one or the other from there. So
Can you talk about ASTM flammability and toxicity standards that Tedlar meets?
definitely, I think we do rigorous testing with a lot of our customers as well in the aerospace field, or which go through a lot of flammability and toxicity testing. Now, unfortunately, off the top of my head, I am unable to name all the different, burn tests or ASTM tests, but this is where, I encourage, even sending a little email would be happy to send in our technical data sheets of our Tedlar films, which has a comprehensive list of all this critical information for different testing standards, properties, and properties as well.
Can you talk about the roll widths available and the film thicknesses
Yeah,
that are
so
available?
we do have multiple film thicknesses that we provide depending on needs. So, 1 mil and 1 mil thick films, half-mil thick films, and even 2 mil thick films. So they have different levels of durability as well as can uh, last for different times as well. So depending on the thicknesses, it can be used for rather specific applications that are needed.
Can you talk about, does the film change colors or whiten during cold forming?
That's a great question too. So the answer is no. So any of the forming processes as well, the color stays the same. And that's why, when it's used in roofing for that reason, because you don't really see any discoloration or cracking at those seams or those bends in the metal laminate at that sharp angle, and also provides additional protection from those areas where damaging could lead to corrosion or rust when you use any other competitive alternative polymers versus PVF.
Can you talk about weathering and outdoor durability?
Yeah, so definitely. We do a wide range of internal lab scale accelerating weather testing through, salt spray testing, different temperature ranges, UV exposure, and in our R&D lab, we do have, a lot of the testing equipment that we use to rigorously test our samples and composites. But also to this, we have, a test setup in South Florida where we regularly send samples over there for continuous testing. So we do get kind of real world testing and accelerated lab testing combined. And we could see over time just the long-term performance of Tedlar. And we do have pictures of and examples of a lot of our laminates over wide time periods or extended time periods, showcasing its durability over that time frame.
Let's see. I'm looking at one that I feel like is more specific. We have a question about vacuum forming and deep draw. I'm not sure exactly what they're asking. Maybe you can address typically how the material performs under vacuum forming.
Yeah, sorry. I mean, let me take a look. And under vacuum forming and deep draw. Sorry. Yeah. So, yeah. In fact, it's there's a wide range of different thermoforming applications in which Tedlar can be formed into more 3D shapes. In fact, you could even take Tedlar films and line it into a specific mold as well, and have it make a specific three-dimensional shape. But be happy to talk to you about many different processing conditions that are capable for Tedlar films, and specifically what may be the technical requirements or technical processing requirements required. We do have a lot of laminating guides and manufacturing guides, which do have a lot of that information and details that we'd be happy to, share that critical information with you for your specific needs as needed. So
cool. We have a follow-up color question. So color does not change, but opacity could, correct?
It's a good question. Would definitely like to get back to you on that. And I would be happy if you would reach out to me with any of your specific questions.
Okay.
Yeah, thanks.
Custom colors. Can you make custom colors?
Oh, yeah. So yeah, so we do have, we're not just limited to, a select few pigmented Tedlar films. We could also make, select custom colors, but in terms of a custom color order, there are certain volume requirements that are needed. So because of that, please reach out to us and we could help answer, what requirements are needed and for custom and specific colors of films. Yeah.
Okay. I think you might have touched on some of this, but I'm going to read the question
Sure.
just so you can add anything that seems relevant. How does Tedlar differ from PVDF or ETFE?
It's a great question. So I have a good chart to compare it to other fluoropolymers. Yep. So in fact, looking at PVF versus other similar polymers, we can see that, PVF really offers a range of many different desirable characteristics in manufacturing and also in end use. And unlike, PVDF or ETFE, first and foremost, PVF or Tedlar PVF is not a PFAS material per any current regulatory definition, first and foremost. But also, Tedlar PVF is highly flexible. It's also chemically resistant. And, Tedlar film is also 100% PVF fluoropolymer. So it does not contain any other acrylics or any other acrylic additives. So what you're really getting is 100% fluoropolymer, ensuring, durability and its cleanability, and that the color does not fade after a long time. Yeah.
For concave female composite molds, can Tedlar be hand applied without bridging and bubbles?
It's a good question. In fact, this is more on the processing side of things. I would definitely encourage to reach out. One member of our team would be happy to, answer more processing related questions. But along those lines, and if that helps, we do offer different Tedlar films with specific shrink properties as well. So if it were to be hand applied as well, it could then shrink to meet, the specific shape and size of a desired part throughout the processing application.
Okay. Another processing clarification question. The Tedlar production process is cast extrusion.
So we provide Tedlar film as film rolls, and this is where they would then be implemented into your existing production lines or manufacturing capabilities from there. So yeah, we would provide you Tedlar film, and we do also provide Tedlar resin for other coating needs, but it's beyond scope of this.
Great. Okay, well, as we kind of run up on our time here, I want to just thank you, Sanahan, for a great presentation. We really appreciate you taking the time today.
Thank you. And just once again, for everyone, please feel free to reach out to us on LinkedIn or to my email, and be happy to connect you with a member of our team or answer any questions.
And if you have a question that wasn't answered today, rest assured the presenter will be getting copies of all the questions, so he can reach out directly with you, and as well as the ones that we kind of you felt like needed further clarification. So thanks again. I'd like to thank our attendees for taking the time to join us today. We really appreciate you being here and spending time with us, and hope you'll join us again for the next Composites World webinar. For more information, you can visit compositesworld.com/webinars. Thanks again. Have a great day, everyone.